In this lecture, we will talk about functional dependency. What is functional dependency? How to find out functional dependency from a given table or relation, or you can say whatever is given, that is functional dependency or not, to check that is functional dependency or not. See, this is very important topic for the point of view of normalization. If you get it, what is functional dependency, the basics of functional dependency very well, then you can easily get the normalization concept, all the normal forms. If you are not good, if you don't know what is functional dependency, how to check out that this is functional dependency or not, or you can say how to write down functional dependency of a table, then you will never get the concept of normalization or the normal forms, right? So now we will discuss what is functional dependency in this video with a small example, and after that I will discuss with a complete example. We will discuss all the functional dependencies from that table. We will draw functional dependencies from that table, right, with the help of proper example. See, here functional dependency is basically, we represented something like this with the help of one arrow, right? If I say, see, as the name suggests, functional dependency means dependency. Something is dependent on another thing, or some attributes are dependent on another attributes, like this, right? Now, if I say x determines y, let us suppose I am taking a simple example. I am taking one relation, or you can say one table. There I have only two attributes, right? These are having some values. This is a relation R or a table, right? Now, if I write the functional dependency is x to y, means x determines y. It means if I tell you value of x, then from this table you can search value of y. See, here x determines y doesn't mean that I give you the value of x and you will compute the value of y. Something like this. See, suppose y is equal to x square plus 5x. So now y is dependent on x, and if I give you x is equal to 5, then you can tell me what is value of this y. That would be 50. Here we are computing the value of y by putting value of x here, right? Functionally dependent. This y is functionally dependent on this x. But in this case, here in the case of DBMS, I am discussing functional dependency. In this case, this is not a case. Here I just give you the value of x, and you can search value of y from the table. It's not like that you don't have any table and I'll tell you value of x and you will tell me value of y by calculating or by computing something. No, for this you need a table. From the table, according to value of x, you can tell me value of y, right? That is, you can say, a functional dependency. It means y is, you can say, functionally dependent on x, or you can say x determines y. Fine. So here x is known as determinant and y is known as dependent. Now let us fill this table with some values, and then we will see in this table this functional dependency exists or no. You need to follow some rule to check that this is a functional dependency or not in this table, right? I'll tell you all the rules. Now let us take in this table I have these values. X value is 1, 2, 3, 4, y value is this one, this, right? Now see, if I tell you that value of x is 2, now according to 2, tell me what is value of y from this table. Obviously we will search value of y from this table, and the searching would be based on some rules. See now what are those rules. I am saying value of x is 2. Now can you tell me value of y? Find out where is x value, 2, value of y is 1. Yes, I can tell you value of y is 1, right? Now suppose here I have inserted one more row, that is this one, 2 and 5. Now if I say value of x is 2, now tell me value of y from this table. Search what is value of y. Now x is 2, y value is 1. But again I have x is 2 and y value is 5. Now which value you are going to tell me, 1 or 5? I cannot say. So this cannot be a case. See, the same example, if y is equal to x square, right, and x is equal to 5 I am taking, right? So now for x is equal to 5, y is equal to 25, right? X is equal to 5, y is equal to 25. If I write x is equal to 5, y is equal to 35, then definitely it would be wrong. That cannot be a case, right? When you functionally compute a value, right? This is related to this thing. Here we are not computing, but we are searching, but that logic is same. Now x5, then at the both place y should be 25, it cannot be 35. If x value is same, y value should be, or you can say must be same. I hope you are getting my point, right? So here x value is 2 and 2. So y value must be either 1 and 1 or 5 or 5, right? It cannot be a case that here y value is 1 for this 2 and for this 2 y value is 5. So here we cannot say that x determines y, because obviously x cannot determine y in this case. Because on the base of x you cannot tell me value of y, then how can you say that x is determining y? We cannot say. So this is not a functional dependency in this case, right? If this is the case, fine. Now see, here second case may be there. If I am taking x is equal to minus 5, then also y is 25, right? But vice versa is not true. If y is equal to 25, right, and in two tuples y is 25, it doesn't mean that x should be same, that x should be 5. Here for x minus 5 also I can get y 25. This case also we will discuss with proper example, right? Now, for now, just keep in mind this thing. If x value is same in two rows or in two tuples, then y value should be same, y value must be same. Now see, this table is there, I have removed that row. Now if I say x value is 4, tell me value of y. Can you tell me? Yes, x value 4. No repetition of 4 is there in this x, so I can tell y value is 3. Right? Same example, like in my class I have 60 students, and obviously the roll number of every student is different, right? For the unique identification, roll number is there. Now if I say roll number 15, tell me your name, then obviously only one student is having roll number 15, right? Means with the help of roll number I can determine each student of my class. But now suppose in a seminar hall I am taking a class, and there I have student of CS as well as EC department, right? Now there if I say roll number 15, tell me your name, then I cannot determine with the help of roll number that the name of the roll number 15 is what, because in CS also there would be roll number 15, in EC also there would be roll number 15. Yes, suppose in CS I have 60 students, there also I have 60 students, right? So here I cannot determine with the help of roll number. So here roll number determines name is not a functional dependency, right? But in previous case it was functional dependency. So it depends based on the relation, whatever relation you have, based on that relation you need to find out functional dependency, right? Now formally how to write down the definition of this functional dependency. See, functional dependency x to y means x determines y. This is true on a relation if, see, I am taking the case, here I have 2 and here I have 5. Now see, here x determines y, that is not true because x value is 2 but y value is here 1, here 5. If here I can write 1, then this would be a functional dependency, right? So now if in two tuples like t1 dot x equal to t2 dot x, fine. Here t1 and t2 means any two tuples and x means x values. Like suppose I am taking this tuple and this tuple. t1 dot x is 2, t2 dot x is also 2, right? If this is the situation, see this is not an assignment operator, this is I am comparing the values, right? Then y value must be same, right? Same case. Here y x square, x is 5, then y is 25. Again I am writing if x is equal to 5, then y must be 25, right? That is true. But here if I write 35, then that is wrong. That is not a functional dependency now, right? So now then t1 dot y equal to t2 dot y. This should be a case, then only you can say that x, this is a functional dependency, x to y, this is functional dependency on this relation, right? Now here check, if this is the table, then I am taking any two tuples. Suppose I am taking this tuple first of all, t1 and t2, right? Now check, if t1 dot x is 1, t2 dot x is 2. Is this true? No. In that case, if this is not the case, this is not true on the for the two tuples you are checking, then no need to check for y value. Y value may or may not be same, right? See here you can say y value is same, but it doesn't matter, because if this is true, then only we will check this condition, then only this must be true. But it's not like that, if this is false then it must be false, or if this is false then it may be true, it may be false. We does not check this condition if this condition is false, right? So here we will not check y values, right? Now suppose I am taking these two tuples, 2 and 3. Now value is 2, in this tuple value is 3. Is the same? No, we will not check y value. Now check for this tuple, this one and this one. This is suppose t1, this is t2. t1 dot x value is 2, t2 dot x value is 2. Now this condition is true because both are 2. Now you must check this condition. Now check t1 dot y. t1 is this, t1 dot y is 1 is equal to t2 dot y. t2 is this row, t2 dot y is 5. But this condition is not true in this case, right? So this is not a functional dependency here. I hope you got my point. Suppose I am writing this one. Now can I say this functional dependency exists in this relation? Yes, because see, x determines y, means check out for any two tuples, check out value of x. For this and this, value of x is not same, so we are not bothering about value of y, will not check. For this and this, values are not same. For this and this, values are not same. For this and this, values are not same, right? Means no value of x is repeating in this case, right? If the value of x is repeating, then only we care about the value of y. But here, every value of x is unique, so this would definitely be a functional dependency. If every value of x is unique, then definitely we can determine value of y from x. The same case, if in my class roll number are different, so every student is having different roll number. So definitely I can identify the name of student from the help of roll number. Name may be same or not. See, roll number is 14, roll number is 15, right? Suppose both are having name Nisha. But I don't care about this because I have what? Roll number 14 and 15 to identify. If I say 14, then she'll say yes ma'am. If I say 15, then she'll say yes ma'am, right? It means with the help of roll number I can determine each student. So yes, there is a functional dependency from roll number to name. Now one more point, here this x and y, here I am taking x and y only one attribute, but x and y can be set of attributes. There can be one attribute, two attribute, 3, 4, 5, right? So these are set of attributes. This is very important concept, very important point, right? Now let us discuss the functional dependency with the help of a proper example. I am taking a proper relation. I hope you got what is functional dependency. Fine. Now let us take this relation. The name is student having 5 attributes, roll number, name, marks, department and course, and having 6 tuples or 6 records, you can say, right? Now we will check if you get what is functional dependency and why I am writing this thing. I hope you got it very well. Now you can easily tell me if whatever I am writing that is functional dependency or not in this table, right? Now suppose if I am writing that roll number determines name. Now check with the help of this formula whatever we have derived, right? Now check for any two tuples, right? First of all, I am taking this tuple and this tuple, t1 and t2. t1 dot x, here this is x, this is y now, right? So now value is 1, t2 value is 2. So this condition is not true. So do we need to check this condition? No, we don't bother. Value of this name may be same or not. I don't care, right? Now check, suppose this is the tuple T1 and T2. Now here also T1 value of X is 2, here we have 3. So no need to check value of Y. For this also, for this also, for this also. Now here you can say if there is no repetition. Now see, by looking at this database only I can say that in roll number I don't have any repetition, right? So no two tuples will have same roll number value. So no need to check for Y value, no need to check for name. I can say that definitely it is a functional dependency, right? If repetition is there, if this is a case, then only we will check this condition, right? Now suppose I am writing here name determines roll number. Now check, is this a functional dependency or not? Now here this is X, this is Y, right? Now you need to take care. Check, this is X, means take two tuples. This two tuple I am taking. So value of this X for this one is A, this is B. Values are not same, so we don't bother about roll number. Now check for this and this, values are not same. Now see, this value and this value is same. So here I got repetition. No, just check for the repetition values, right? That would be very easy for you. Now for this tuple, the name is A, for this tuple, name is also A. Now you can easily check, you can easily say that this condition is true now. So this must be true. Now check value of Y. Now here Y is roll number, right? Is 1. For this tuple value of Y is 3. So this is not true. It means this is not a functional dependency. Now see, I am taking suppose roll number determines marks. Now see, I can see that roll number is X, now this is Y. So no two tuples of roll number is having same value, means no repetition is there in the roll number. So definitely it would be a functional dependency. No need to check for Y values, right? Now if I say department determine course, now it means I will tell you value of department and can you tell me what is the course from this table? Can you search the course? Now if I say department is CS, now see, department is CS, now here course is C1, but again department in another tuple is CS, but here course is C2. So which one you will tell me, C1 or C2, right? I cannot tell. So this you can say this is not a functional dependency, fine. Or same with the help of this formula you can check, this is X, this is Y. So check out the tuples which are having repetition, this and this is having repetition, this is having same value. Now for this check the value of Y, here we have C1, here we have C2, but value of Y should be same. So this is not a functional dependency here, right? Now if I write course determined department, check, if I say you course is C1, now tell me the department corresponding to that. Now course is C1, right? Department is CS, but course is C1, here department is EE. So that is confusing. What should I tell you, CS or EE, right? Same you can check. Now this is X, this is Y using this formula. Now take these two tuples T1 and T2. T1 dot X is C1, T2 dot X is C1. So this condition is true. If this is true, then you will check the Y value. Now check, this is Y. Now T1 dot Y is CS, T2 dot Y is EE. Now this is not true because these are not same. So this cannot be a functional dependency. Now you guys will tell me, is this a functional dependency or not? Marks determines department from this relation, right? Now I have told you the X and Y may be set of attributes. Here I am taking only one attributes in X and Y. Now suppose I am taking set of attributes. See, now let us check roll number and name. I am taking both determines marks. Is this a functional dependency or not? Now X is having two attributes. Now see the combination of these two. Consider it as a 1, means this is what X now and this is what Y now, right? Now see roll number and name. So now see from here I can easily tell roll number is not repeating. So definitely the roll number and name combination will not repeat. If here I again write 1, right, and here I write A, then there would be a case that if I take this tuple and this tuple, then combination is 1a, here also combination is 1a. Then this is true. Now you have to check for marks. Here marks is 78, here marks, suppose I am taking 90. So this is not a case, means here marks are different, so this is not a functional dependency. If I am writing here 78 again, right? So now only in the two tuples I have repeating values, no other tuple is having repeating values. So for this only you need to check marks are same, so this is a functional dependency, right? But in this case, no repetition is there in roll number, so definitely there would be no repetition in here, so definitely it would be a functional dependency. Now check, if I say name determine marks, is it a functional dependency in this case? Now check, name, if I say name is A, now tell me the marks. From this table check, the name is A, mark 78, but again I have name A, marks is also same 78. So it doesn't matter this you will tell or this you will tell, right? Because name is same and marks are also same. So now this is, you can say, a functional dependency. Like same in B and B, name is same in two tuples, X value is same, Y value is also same, right? Again we don't have now any repetition because here I have C, here I have D, so no need to check here. See here Y value is same but X value are not same. So if X value is not same, then we will not check Y values, it may or may not be same, right? So this is a functional dependency in this case. See, let us take this example. Same, two students in my class are having name Nisha and both students are having same marks. So if I am recording their marks in my register and if I call the name Nisha, tell me your marks, then obviously both are having same marks, so both will tell 78, so there would be no problem. Like either this will, she will tell or she will tell, there would be no problem. Problem comes when one is having marks 75, one is having 78. Now I'll say Nisha, tell me your marks. Now suppose I am asking marks of this one and she will say 78, so I can record her mark 78. That would be a problematic situation, right? So this is the case here, same. Now suppose I am taking name, marks, determine, department. Is this a functional dependency or not? Now this complete is what X and this is what Y. Now name and marks, this complete. Suppose take any two tuples, check out the values. Suppose this and this, here combination is A78, here B60. So the value of X for two tuples is not same, no need to check Y value, we don't care about Y value. Now here I am taking suppose this tuple and this tuple. Now see, A78, value is same, X value is same. Now check value of Y. I want to determine department. Now department is CS, for this also it is CS, no problem. Now this and this combination is also same, B60. Now department EEE, no problem. Now we don't have any repeating combination of name and marks, right? So now this is also a functional dependency in this table. Now if I am taking here name, department determines department, name, marks, determines department, course. Now this complete is X, now this is Y, right? See, now X and Y are having set of attributes. Now how to check this type of dependency? Name and marks, see the combination. Now only check the combination which is repeating. See, in this tuple combination, in this tuple the same combination. So I am taking these two tuples, right? For these two tuples, check the value of Y now. If X value is same, check the value of Y. Y is now department and course. Department, course, both are Y, right? Now you need to check the combination. Here CS and C1 for this tuple and for this tuple CS and C2. Although CS is same, but here we have C1, here we have C2, and here Y is complete, this one. So this is not same, this is same, but Y value is not same. So you can say this cannot be a functional dependency, right? See here now, if for any one combination, see here for this and this, right? I have checked only for T1 and T2 for one combination and this combination is not same, so I can say this is not functional dependency. No need to check for further. If you found one that is violating this condition, if this is true but this is not true, then you can say at that time only that this is not a functional dependency. So now I hope you got what is functional dependency and how to find or how to check if a particular given is functional dependency or not on that table, right? Now I'll give you some practice problems and you can check out. So you can check these are functional dependencies or not on this relation, right? And if you want, you can tell me in the comment box, or if you will not tell me in the comment box, then you can practice these. That would be enough for me, right? Now in next video I'll discuss types of functional dependencies and properties of functional dependencies, or you can say Armstrong axioms. Fine. So now I'll see you in the next video. Till then, bye bye, take care.